Hi, so in this module I want to talk about one of the challenges to keeping our environment clean. Whether we're talking about the environment within cities or regionally or globally, the reality is that those who are most responsible for environmental damage don't necessarily suffer in proportion to their role in causing it. So on the flip side, those who seek to do something about an environmental problem, whether it's an individual or say a city government or a country, their efforts at mitigating a problem sometimes inadvertently affect someone else, say downwind, whether it's beneficial or possibly an adverse consequence. There are oftentimes these unanticipated consequences that affect others. And so I'll explain this concept a little bit more and give some examples as we go forward. But first, in economics, there's this concept of the free rider problem. This is when people who benefit from resources or public goods or services actually don't pay for them. And there are many examples of this in our everyday lives. You can imagine if you ever use Wikipedia but don't pay for that service, there is an infrastructure cost for them to maintain it. Likewise, with the thousands of apps out there that are in the sort of shareware realm, where the developers don't charge you up front, but expect and hope that if you use and like their app, you'll contribute something. But probably the most common example of free rider problems in our everyday lives, I'm sure you can come up with others, but is NPR, National Public Radio, where they get something like 60% of their funding support from individual and corporate donations, but there's evidence that suggests that only about 10% of listeners actually donate. So obviously a big free rider problem for them. There's also a related aspect of the free rider problem, which is when the production or cost of goods does not consider some of the external costs or the externalities. This is particularly true in the case of ecosystem services. There's also a parallel to the free rider problem concept in the environment. So this is true both it's true at all scales. So we're going to start at the global scale. When you think of the question, who's responsible for global warming? The answer really depends a bit on your perspective, and the numbers do fluctuate a bit depending upon the year and the source of the data. But if you think in terms of individual contributions to greenhouse gas emissions, the US is by far one of the worst, with Americans emitting at about 3 times the rate as the average person in the rest of the world. But there are some complexities to unpack here. For example, you might look at comparing Canada to the US and say, wow, Canada is actually just as bad as the US pretty much. But you need to actually recognize that every country is subject to its own local environments that it has to deal with. So there are many countries for which the local thermal environment, the winter conditions are so harsh that it's actually surprising Canada only uses 15.3 tons of CO2 emissions per year for their population because they're exposed to such a harsh cold climate. But if you, on the other hand, look at which countries are most responsible for contributing to global warming or CO2 emissions specifically, you need to multiply those numbers, the CO2 emissions per capita, by the actual population of the country. And then you get a different ranking of who's most responsible, and perhaps a more relevant and significant ranking. And you see here that China and the US are clearly the leaders of CO2 emissions by percent of the total world emissions. But as I mentioned earlier, those who are most responsible for causing a problem don't necessarily suffer in proportion to their role. So here I want to introduce the framework concept of vulnerability to talk about which countries are most vulnerable to climate change. So vulnerability has 3 components. First of all, there's exposure. So if we think about climate change, when we think about exposure, the first thing we think about is warmer temperatures, so high temperatures, but there are also secondary effects associated with the fact that, well, the temperature's high, therefore the sea surface temperature is high, therefore there's a contribution to enhancing and strengthening tropical storms. There's also a shift in precipitation patterns, which combined with the temperature can lead to severe drought and so forth. So those are some of the exposure pathways that we're interested in thinking about climate change vulnerability. But then the next question is, well, who's sensitive? And so the countries or individuals who are most sensitive are the ones for whom this kind of exposure has a significant health or economic impact. And then the final piece of the vulnerability puzzle is adaptive capacity or lack thereof. And so you can imagine that location or wealth of the economy are factors that influence our adaptive capacity. The United States has a tremendous adaptive capacity. We do have a lot of vulnerabilities associated with coastlines, but at the same time we have a lot of wealth. We're able to deploy solutions to try to deal with the ramifications of climate change. There are some countries for whom the location gives them no alternatives because their entire countries are going to be inundated with higher levels of sea level. And so when you think about these three elements, it's really the vulnerability to climate change is the intersection of exposure, sensitivity, and adaptive capacity. That's the red area showed here in the middle. So this map here is from the Notre Dame Global Adaptation Index, and it shows the relative vulnerability and preparedness for climate change across 175 countries. So here what they've done is they've created a map with sort of two axes of color. So a readiness, if you look on the lower right-hand corner here, readiness going from yellow to green or from pink to blue, and vulnerability going up. So the areas in red on this map, including most of Africa and South Asia, are very vulnerable to climate change, and they're ill-prepared to deal with its impact. The few countries in blue, including Vietnam and Ghana, Rwanda, are countries that are vulnerable, but are relatively well-equipped or prepared to deal with the ramifications of climate change. Countries in yellow are less vulnerable, but also less prepared. And then countries in green, which includes most of the developed countries, including the US, are both less vulnerable and better equipped to deal with the challenge of climate change. If you cross-reference that map then with the list of the biggest global contributors to CO2 emissions, there's actually very little overlap. India is one notable exception. They're a major contributor to CO2 emissions, both currently and projected into the future. And they're also one of the most vulnerable and least ready countries. So when you look at the countries in red, highly vulnerable but least ready, what comes to mind? Well, according to the Notre Dame Global Adaptation Index, the 5 most vulnerable countries are all in Africa. And if you think about what these have in common, aside from all being in Africa, their per capita GDP ranges from about $400 per year to $1,000 per year. For reference, most developed countries, including the US, have per capita GDP that's between $30,000 and $60,000. So these countries are vulnerable in part due to their poverty and risks related to food security, and several of them are coastal. And so just as the effects of greenhouse gases are global in nature, not respecting borders, the same is actually true with other environmental challenges such as air pollution. So I'm going to illustrate this with examples across 3 scales. We'll talk about intra-urban effects, sort of neighborhoods within a city that are connected, inter-regional effects, so how nearby cities or nearby states affect each other, and then intercontinental transport, how countries affect each other. So as you'll see, the common thread here is that oftentimes the solutions to any of these air pollution challenges are typically dealt with through regulations or legislation that occurs at a political level that doesn't match the level of the impact. So again, just as we thought about the vulnerability framework for climate change, we can think of that in terms of air quality. So exposure for air quality is usually thought of in terms of, well, what's the local air pollution levels, everything from ozone to particulate matter and so forth. The sensitivity has to do with, well, who is most at risk associated with poor air quality? And that tends to line up along the question of age. So the elderly and the very young are particularly sensitive, as are those who have pre-existing conditions. So whether it's asthma or other respiratory issues. And then adaptive capacity, or again, lack of adaptive capacity. So those who don't have wealth, those who don't have good social networks, they are particularly vulnerable as well. So transport of pollution is the final of the concepts here I want to talk about. It depends on residence times of pollution in the atmosphere. So if you think about ozone, its residence time in the atmosphere, depending upon what else is there for it to react with, can be on the order of weeks, CO2 on the order of years, nitrous oxide on the order of hundreds of years, and then nitrogen oxide and nitrogen dioxide on the order of days. So when we think about intra-urban effects and sort of transport issues, one important thing to note is that ozone, so if we're thinking about ozone photochemistry and ozone air pollution, ozone concentrations are a function of emissions of, say, NOx, CO, and volatile organic compounds. Temperature, ambient air temperature affects some of the reactions, and then sunlight, which is the prime ingredient for photochemical reactions. And one thing that we've noticed in some of the work that we've done, and others have found the same thing, is that if you look at an example like Los Angeles, where they're thinking about putting in place strategies to curb the urban heat island, so to cool the city, which will have a direct effect in the communities where they're putting in place, whether it's highly reflective paving or roofing or more vegetation and so forth. But because there's a natural sea breeze from the west going inland, what happens is if you cool the temperatures of the city, you actually decrease some of the reactivity, some of the reactions that are going on in the atmosphere. And so while you still have NOx emissions coming out of the tailpipes of cars, much of this just doesn't, as they say, cook directly there where it's emitted. It's wafted downwind, where it then reacts and creates higher concentrations of ozone. So there are examples where we've modeled the potential benefits to air quality of doing one strategy, whether it's emissions reductions or trying to cool the air temperature. And we found that yes, in fact, that does have a local effect of reducing the ozone over that modified area. But what we've found is that downwind, sometimes the ozone is actually increased. So even within the city of Los Angeles, you can have those kinds of effects. And that, of course, translates to other cities as well. But then there's this question of interregional effects. And so going one scale higher, just this year, there was actually a really good example of how nearby cities can affect each other's air. In fact, nearby states. So in January, the state of Connecticut joined the state of New York in suing the EPA over failure to regulate ozone-causing pollution from the Midwest, from Michigan, Pennsylvania, and West Virginia. And so there's a quote here from the commissioner of the State Department of Energy and Environmental Protection in Connecticut. He says, "Connecticut has some of the strictest air pollution regulations of any state in the nation. Unfortunately, the air that our residents breathe is some of the worst in the Northeast due to pollution blown in from upwind states." And actually in June 2018, a federal judge ordered the EPA to take steps to deal with this effect. So it's a real challenge when a state, in this case the state of Connecticut or New York, can do whatever they want to try to clean their air, but they're at the mercy of what's coming from upwind. And so here's just a map showing the scales that we're talking about. So from, say, Michigan, maybe emissions from Detroit travel 300 to 500 miles to get to Connecticut. And some of the emissions in Pennsylvania only have to travel maybe 200 or 300 miles to get to, say, New York City. But one other thing that's kind of interesting here is more and more we're finding urbanized regions where the cities are growing together. And so this just amplifies this challenge of the downwind effects of what one city is doing impacting another city. And the cities have to learn how to work together. They have to use regional governance strategies to try to deal with these problems that don't respect political boundaries. So a good example is this sort of urban archipelago of Washington, Philadelphia, and New York. And so the final thing I want to talk about is intercontinental transport. So certain air pollutants have long enough residence times in the atmosphere that they can actually be transported over intercontinental distances. This includes ozone, some of the ozone precursors, particulate pollution, and mercury. And so, for example, pollution from Asia is reaching the US and it's contributing to ozone pollution, particularly in the western states. And research suggests that regardless of what we're trying to do, say on the West Coast states, to improve air quality by, say, cutting NOx emissions, the transport of pollutants from Asia are actually offsetting by about 50% the gains that we're making through our own controls. So they're significantly hampering our ability to clean our own air. And this is just a map that comes from a recently published paper in Atmospheric Chemistry and Physics that looked at this question both through measurements and models to confirm, first of all, a correlation between the emissions in eastern China and the resulting ozone air pollution in western US. And this map actually shows, you can see over the Pacific Ocean, the trail of higher levels of, this is the 8-hour average ozone concentrations over a very long period of time. So let me finish with a summary of some key points. So the first point is that those most responsible for pollutant emissions are oftentimes among the least at risk of suffering any consequences. Vulnerability is the intersection of exposure, sensitivity, and lack of adaptive capacity, and has applications across a broad swath of environmental challenges, including global climate change. And then pollution respects no borders. So effective solutions require some level of cooperation across political boundaries.